Thanks very much, Martin. Moving on from there, we have a new talk, but again, talking about Elasticsearch. We're going to talk about searchable application logs in production. Please welcome, he's coming all the way from the United States Virgin Islands. He works for Tommy John, which is a New York-based company. Please welcome Brian Buchalter, everyone.
Thank you. This mic's not hot. Thanks, Gregor. All right. So I know it's been a little difficult to see some of the slides. So in the Slack channel is a link to this deck, so you can watch it from the convenience of your seat. Please, I'm going to take that cue from Gregor here and use the interactive questions. And there's also a companion repo that's going to go with this talk. And this is kind of your take-home activity that you can really actually do everything that I'm going to do in this talk just using this README here. And this is very much a how-to talk because I'm operating under assumption that I actually want to validate right now. So but actually, we'll hang on for that for just a second. First, I want to tell you a little bit about me. Because I think the reason we come to these conferences is to kind of get to know each other, and putting a face to a name is great, but learning a little bit about each other is how we're going to strengthen this community. So yeah, that's the U.S. Virgin Islands. That's the island of St. John, where I live. It looks really beautiful, doesn't it? It is really beautiful, but not as all paradise in paradise. I've talked to a few of you recently. The electricity might turn off on the island because they didn't pay their fuel bill. So that's kind of the things that can happen on these remote islands, where a magical blend of incompetence and corruption can happen. But enough about that. There is actually still a lot to enjoy on the islands. I'm raising my family there. This actually is a very old picture. That's my daughter Coral. She's named after Coral Bay, and I have a son who's Cruz Bay. My wife was born and raised there. We're multi-generational household. It's really a lot of kind of unique opportunity, and that unique opportunity is made possible in large part because of this community and the Ruby community at large. And this is my first chance to really acknowledge that community and say thank you for making it all possible for all of us. So cheers, thank you. Yeah. Okay. So back to business. Why are logs important? So I'm gonna do something that I probably shouldn't do, which is demo live things. So this is our production instance of Cabana right now, and Cabana is this thing that you're going to learn about in this talk. And this also gives me a chance to introduce Tommy John, the company I work for. So Tommy John is a menswear company in Manhattan, and we make really comfortable underwear. I hope this doesn't breach talk guidelines, conference guidelines, but we make really comfortable underwear. If you want to talk about your underwear with me, I'm okay with that. There's probably several guys here from Stembo who can tell you about their comfortable Tommy John underwear. I'm a cool cotton guy. I think that natural fiber really breathes nicely in the Caribbean, and you might be wondering why I'm showing you this right now, but that's because this production application, those logs. I'm logged in here right now. I can now see all that interactivity that was just happening, and I get a level of real-time data that is pretty good. And my pitch here basically is that who here has ever gotten a call from customer service and said, hey, I got a couple of orders that are a little weird. Can I see? Yeah, exactly, exactly. Okay, now, if you don't have this, you're going to log into your console and you're going to be like, yeah, those orders are really weird. Have a nice day. I can fix them or whatever. But you can't see how that order got into that state without production application logs. So I want to do another quick survey. How many people can do what I just showed right now? Okay, let the record show a non-trivial portion. So maybe about half says they can do this right now. So cheers to you. How many of you that said, no, I don't have this capability, want to do this? Let the record show I have not wasted my time. Okay. Yeah, we did that. So here's my agenda. All right, so I have a 5-parter. Because there are 5 parts, we're not going to dive too deeply into any of them. And I'm going to try and give you a blend of a little bit of theoretical about Elasticsearch and some of these things, and really just enough to kind of help you get past the gotchas. And really a heavy dose of practical. My goal in this is that all those people who said, I want to do this, can like literally go do this on Monday. It is really not that hard anymore. It used to be, and now it's not. So let's go do it, and I'm gonna do it. So yeah, follow along at home. So the first thing we need are logs. And like that kind of sounds obvious, but you know, Rails default logging. Like, oh my God, why would you ever do that? We really need one request and one line of output. And I particularly want my document in a JSON format. So, you know, I'm gonna, again, do the things I'm not supposed to do by jumping out of here and going into this demo repo, right? And I've already basically done these steps, and I wanna show you those steps right here. So I'm in my sample store. And hopefully you can see the top of that console. This is the Rails server. Look at those beautiful logs. They're so nice. And then here are the logs we get from that we do want, that I want to ship to Elasticsearch, right? So I've got a tail here, and I got my Rails server there, and that's that kind of step. And I want to just basically talk about what's in this gem. I called it Solidus log rage because I was like, yeah, everybody will just use log rage, but you don't have to use log rage. Log rage is just one tool. You could roll your own. You might already have this, and you just don't need this at all. But this I thought was kind of neat. There's just a little generator in this repo, and you're going to configure some logging, and you're going to tell log rage or whatever tool you use the data you want to be able to look at in your logs. I think there's some data that's more important than others, but that's your decision. You can customize this however you want. One of the little gotchas at the beginning was like, oh, how do I get some Solidus specific data? Like, what's the order number? And we can just use this append payload module that gets decorated into application controller. And this is just part of the active support instrumentation, lifecycle. So you can basically tack anything else that you want. And one of the things I'm going to work on for this demo is how to integrate with Solidus auth devise. There's a couple more gotchas there, mostly because we don't always refer to spree current user consistently through the API and in some other places. So that's on the to-do list for this repo, but you kind of get the idea. So yeah, I mean, that's it. I mean, you got logs at this point. But it's not enough to just have the logs. You kind of want to make sure that they have not only the things that you care about, but also some things that you actually don't want. So one of the first gotchas that I encountered was I'm like, yeah, I want to be able to search by my query params. Like, who's putting in this into a query param. That was a horrible idea. I started getting these love letters from Elastic Cloud saying like, your node is rebooting because you have no memory. And I was like, why do I have no memory? And I was like, oh, user input as keys in your document is a horrible idea. So don't do that unless you want to spend a fortune on Elasticsearch nodes. Generally, you just want your document structure to be stable. And that also makes it easier to search over time. Now, if you do really care about a particular param, pull it out and put it in the document consistently. And it has a fixed key, and sometimes the data is there, sometimes it's not. But don't make my mistakes. So yeah, some things to consider. One other that I thought was kind of like a production lesson learned is like make sure that you include feature flags or experiment flags in that logging, because again, like we're trying to trace this customer journey, right? How did he get this order in this state? And part of why you want those flags is so you can follow the execution path of your code. And if you don't have that information, the mystery will remain an X file, okay? So at this point, I'm gonna say check box on item 1. We have some logs. They have the data that we want and the data that we don't want. And we're gonna look at now basically setting up an environment to send that data to. So that's this bubble section here, Elastic Cloud, which is basically just a managed hosted version of Elasticsearch and Cabana together. And you also get security, things like that, which don't actually come with Elastic Cloud by default. So we're actually going to spin up a cluster right now and start sending those logs to that cluster. It's really that easy. I've pretty much done these steps. You feel free to do them at home at your leisure. What you get at the end of that is this nice like, hey, let's just go ahead and make a cluster. And in like true cloud magic fashion, I can just change these things and I can have redundancy, and like the price is pretty good, $85 a month for a 1 gig memory cluster with 2 nodes for redundancy. I don't know, like that's a pretty good deal to solve the X files of your store. I'm gonna just go ahead and stick with the 1 for now because I'm on my free trial, and we're gonna go ahead and start creating that. Now, once that gets going, you're going to get this magic password. Don't lose the magic password or you'll have to make another one. No big deal, but we'll come back to this in a second while the cluster's booting up. So once the cluster's booted up, we're gonna get a screen like this, and we're gonna get this HTTPS endpoint. And this is your kind of like gateway into Elasticsearch. This is the API endpoint, and you heard this from Martin, but it's really true. The Elasticsearch API is very robust, very well documented, and I think it's actually kind of fun to play with, to learn a little bit about Elasticsearch. You can use these Ruby gems and like magic out of the box, but I actually thought the API was a really fun way to learn about how these clusters are working. So really the first thing I did was copied in this, this host name into an environment variable in a window, and I just asked it, how many documents are in my cluster? And hey, security, like right there out of the box, and you're like rolling your eyes like, what kind of platform is this that this is like a feature? Well, it actually is, and it's something that you get for free when you use Elastic Cloud, but be mindful that if you do say like, I don't need to pay for this, I can AWS and package install, like there's some out of the box benefits to using that service. So yeah, now I'm gonna pop in this Elastic Pass, and I'm gonna ask the question again, and look at that. I got no documents, yes. That's actually a success, right? So let's do that right now, okay? So I'm gonna go here, And I got this, and I'm going to export ES pass. Okay. I'm going to press OK. And I'm going to grab my ES host. And then I'm going to do what we all do when we're learning stuff. And I'm going to copy and paste. And like this thing is live. And that's it. Like step 2, done. But I think there's a couple more things to talk about here in cluster land, which is the word index. The word index is kind of overloaded in Elasticsearch land. So the index as a noun is kind of like a table in a database. When you index a document as a verb, that's kind of like inserting a row into that table. And then the inverted index on that document is kind of what makes Elasticsearch kind of magic, which gives you that instant response over huge document sense like we saw in Martin's example. So when I say it's time to index the documents in the index, bear with me a little bit, but those words have meanings that are not always apparent, but really spending some time with the documentation is going to be your friend. So yeah, we can now really throw a document into that index just blindly. Like we don't have to do anything. We don't have to do mapping. We don't have to tell it anything about anything. We can literally just send a put to an arbitrary index name and an arbitrary document type. You can identify it or not, and it will just hold on to that document for you and version it and actually kind of be sensible about the types. Like, hey, look at that, that's an integer. And it can parse the dates correctly. I didn't use one in this example, but it's like Elasticsearch is all about trying to just get out of your way. Which is incredible considering how powerful and complex that tool is. Hey, look at that. We've got some documents, and now that we have that document, I started going well, hey, what's this shard thing all about? And this was the next big gotcha that I hit when I started, sending data to my cluster. I was like, oh, hey, look, I'm still getting those out of memory love letters from Elasticsearch. I wonder what I'm doing wrong now. Okay, so it's kind of time to figure out really what's going on under the hood, right? Because up to this point, I pushed a button, I sent a document, everything is happening, I'm happy, but now I have a problem. And I don't know why I have a problem. And it's because I don't understand some core concepts about Elasticsearch. And one of those core concepts is sharding. So a shard is basically a copy of your data. And by default, every index gets 5 shards. Is that a good idea? Well, I did like every other person who got these errors, how many shards should I have in my cluster? Why am I running out of memory? Blah, blah, blah. And everybody's like, it depends. Thanks. So, what does it depend on? Well, okay. A shard is like an Apache Lucene instance. It's actually a running instance of the search engine. And the reason why they give you 5 is because they're assuming this read-heavy operation and that you want to be able to query. It's kind of like the unicorn workers, right? If you only have one running Apache Lucene index, you might keep clients waiting. For this particular use case of production logs in a probably small development team, 5 might be overkill. And then you start thinking, well, I'm going to kind of follow the normal practice of 1 index per day of logs, and you don't have to, but that just seems to be the norm. After 30 days, if I use the defaults, I have 150 Apache Lucene instances running on my 1 gig cluster, and I can see I might run out of memory, right? After a year, oh, I have 1,500 Apache Lucene instances running on my cluster. Like, take my money, you know? So we can basically manage our costs and still meet our use case by just saying, hey, we only need 1 shard per index. That's perfectly reasonable. It's important to also understand that when I say we only need 1 shard per index, that's the primary shard. By default, Elasticsearch is going to give you replica shards, by default 1, and spread those shards around over your nodes in a reasonable way. So you don't really have to do anything more than just say, I only want 1 primary copy, and Elasticsearch will still give you that redundancy when you add a secondary node. Okay. Let's just check in here. I might want to make sure that, oh, is the Q&A still working? Doesn't look like it is.
You got to turn it on every time.
Yeah, found a bug.
Turn it on real quick and let people get the URL.
The URL is still in the channel. Is anybody able to ask questions? Is that an issue? Yeah, it's good. Okay, I'm just going to keep rolling with it. So at this point, I've got a cluster. We did this. I have no documents in my cluster. And I'm ready to make sure Elasticsearch is set up the way I need it. So this is where index templates come in. And you saw an example of an index template with Martin's, and his was really complicated, right? Mine's going to be super boring. I really only want my indexes to do 2 non-default behaviors. 1 shard per index. We just talked about that. The second is I want all the strings to be full text searchable. So this is an important distinction to make. There is this idea of strings as keywords and strings as text. And a keyword you can search for, but it has to be an exact match, whereas the text Elasticsearch does is magic of full text search. And that's pretty much it. But by default, those strings are generally going to get treated as keywords. So I'm kind of just like, no. I mean, I want to be able to search, maybe by a partial URL or by some part of the query param or whatever. It's just generally more flexible. So the question is like, okay, I know what I want this index template to do now, which is actually the hardest part, right? Is like trying to figure out what you want Elasticsearch to do, because like this is very much a general purpose tool. And I think it's that is one of the key reasons why this solution isn't like obvious, right? So again, let the record show my efforts have not been in vain. So I've got in this repo a sample template. And again, I'm trying to do the simplest possible thing, and it really has 3 parts. The template here, this field, is basically saying, hey, Elasticsearch, if you see an index that matches this pattern, use this template. That's pretty much it. Pretty simple. And then we get this settings here, number of shards. We talked about that a few times. And then the mappings. And this mapping is, again, the way we want to teach Elasticsearch to work with our data. And I have a very specific field that I want you to focus on. It's the JSON field. Remember, we were using JSON documents, and so by default, when it ingests that document, it's going to put the data you provided in a key called JSON. And I'm telling it to use this dynamic templates thing. And it sounds, what's that? But it's actually pretty simple. I just am telling you I want to treat string as text. So one of the things I find really difficult about Elasticsearch configuration is like, what is generic, like Elasticsearch, and what is specific to my implementation. So mapping is an Elasticsearch idea. JSON is the field that you want those mappings to apply to. This is now an Elasticsearch concept, and you notice it's an array, so I can configure a lot of these for different cases. Very powerful, very flexible, but for us, This is just a name of the template, this dynamic template, and it's supposed to tell you the purpose that it serves, and it's basically saying, hey, if you see something that you think is a string, I want you to treat it as text instead of as a keyword, which is your default behavior. So that's kind of it. Like, it looks foreign at first, but when you unpack it, there isn't that much to it. And as you saw, these templates can get very sophisticated, and you'll want to use maybe better tools than a text file in GitHub. But for my purposes, this meets the need. And then all we have to do is curl that into the API. So I'm going to curl this file that's up on GitHub, and I'm going to send it to _template, and then I'm going to give that particular template a name. And that's it. And I'm going to actually do that for reals. Okay, here we go. Oh my God, so exciting. Acknowledged true. So my cluster now has an index template. That's it. Okay. That was it. One slider. Love that. Okay. Step 4. Step 4. We have a cluster. We have logs. The cluster is ready to ingest our documents so we can find them. We got to send the documents on over. And again, there's a lot of different ways to do this. It used to be Logstash doing this. There are other libraries that can do this. One of the choices that you have is something called FileB, which is a pretty simple tool. That's a binary, and it has some configuration, and it runs on your application servers, and it just reads a file and sends out a document. Can really be that simple. This whole stack that we're talking about, Elasticsearch and Cabana and all this, used to be called the ELK stack. And I just want to highlight why we're switching out FileB for Logstash. Basically, like, FileB's just simpler. It has less features. It has less of a footprint on your application server. So it's kind of just like, Logstash Lite. And that's fine for this particular use case. So, just something to be mindful of there. And so, yeah, let's go ahead and set up our FileB client here. Okay. So let's take a look at what that looks like. And this one's pretty straightforward as well. I've linked to some documentation here for you to go and explore. This is just a YAML file. And we have two sections. We have the FileB section, and we have the output section. And you can actually have FileB output to multiple sources. So it's very powerful, even though I say it's a simple tool. I'm trying to present it in the most simple way. This is how environment variable interpolation is done by FileB. You can also specify defaults by specifying a colon after that. So yeah, I'm basically saying, hey, here's where to find my logs. Expect some JSON. And if you have any trouble parsing that JSON, just put an error message in the error key inside that JSON field. And I want you to send that data straight to Elasticsearch. Here's the host, protocol, username, and here's the index name that I want you to use. And remember, this was how we matched up the template. So we got to make sure the index names that we're using matches up with our index template. And I'm also going to tell FileB, like, hey, I'll handle the templating. By default, FileB comes with like all these really great templates. There's stuff for Nginx and Apache and all the things. I don't really want that in these indexes. Like, that would just be noise. I don't need all those mappings, and I just kind of have a really simple index, thanks. So I'm turning off the templating there. Okay, so we need to get that Elastic log path and the path to that configuration. So that's all, again, part of that Solidus log rage repo. So we wire that up, and I've already got that here. We can just do a quick sanity check by tailing es log path. And that's good. I see some data. I'm going to go here. Okay, so I have a log path, and then I'm going to cat out FileB. What was it? FileB underscore config. Okay, so I have my environment variables. And I want to, in like the testing spirit, I want to see a before and after. And one of the ways I can do that is ask Elasticsearch to tell me about what indexes exist already. Because I'm expecting at this point, when I turn on FileB, that it's going to start shipping logs and creating indexes and documents. So I want to see before I turn on FileB that there's no index. Let the record show there's no index. Okay, and now we're going to boot up FileB. And all this noise comes out, and there's some good noises and some bad noises. Let's talk about what those look like. Harvesters are like, it's all written in Go, by the way. So the harvester is there basically saying like, hey, I found a file. You told me to expect to found a file, and I found one. I'm going to go and start harvesting the log data out of there. The harvester is also going to complain that there's some invalid JSON in there, and that's because, unfortunately, the active support logger puts this at the top of every file it creates, and you can't really suppress it easily, so it just says, hey, I'm going to complain a little bit, but I'm going to keep doing my job. And then you're going to get this non-zero metrics, and that's basically, it's saying, yeah, I actually found something you told me to find. So yeah, let's just go ahead and send another request. And then, yeah, it's like polling here, and it says no non-zero metrics, and then it's going to say, hey, there are non-zero metrics. It's like, boy, you can tell an engineer wrote these log output documents, So let's just wait here with bated breath. The excitement is, what is it, Gene Wilder, the suspense is killing me, right? Oh my gosh. I'm not going to wait. Let's just, well, I should wait. I have to wait. Whoa, there it goes. We got logs. Okay. And now, in true testing fashion, I'm going to curl and I'm going to ask about those indices. And now we have an index. And we have documents. Oh, yeah. Oh, yeah. Look at that. Documents and indices. Yeah. All right, that was really exhilarating. I want you to note that the index's health is yellow, and that's because it wants to have one primary shard and one replica shard, but there's only one node in my cluster. And it's going, hey, I can't really replicate this shard onto the same cluster and tell you everything's going to be okay. So if you see that health yellow thing, everything is going to be okay once you just get your wallet out and pay for another node, and it just takes care of it. Okay, so, oh my gosh, we're so close. Can you feel it? Can you feel it? We're on step 5. We have data in our logs. It is literally shipping live right now from my laptop. All we have to do is see it. So we need this thing called Cabana. And by default, Elastic Cloud does not install Cabana on your cluster. So you're going to go down here and you're going to say, yes, please. And wow, the cloud is so hard. And yeah, and that's doing its thing for your reference here. And we're going to get another URL. And this time, we don't have to use curl anymore. Oh my gosh, yay. So the first screen we're going to see is this thing where Cabana's like, so you want to see some data, but you're going to have to tell me what data you want to see, right? So just in the same way we had to match the index template to a pattern for the indices, we need to tell Cabana, hey, when you're showing me some data, what indices do you want me to pull from? And we also use time series data. And this is another gotcha that I ran into. I was like, yeah, I don't care. I mean, they're just timestamps. Just pick one, right? Well, it turns out at timestamp is the time at which the Elasticsearch cluster ingested your document, which is definitely not going to be the same time that the request was processed on your application server. And if you ever wonder how anyone ever got to the order confirmation page before paying, it's probably because you didn't choose the right timestamp when you were organizing your log output. Gotcha. Okay, so you'll want the JSON.timestamp, which represents the time at which your cluster, your application server processed the logs. So let's pop open Cabana, and we're going to need that same password that we used for the API. We're going to need that for our Cabana cluster. And don't worry, I'm going to even show you how to stop using the root account passwords for all the things here in just a second. So yep, here it is, configure the log pattern. So I'm going to go Solidus log rage _ no dash, click off, select JSON timestamp, create. It's going to show you all those mappings that it was expecting, like, hey, what was the controller name and what was the action? And again, like, it just created all of this by simply seeing the data that was in this hash or JSON. And what's kind of neat about this, by using that dynamic templates thing, we can just add to that as time goes on, and those mappings can get updated, and you don't really have to do a whole lot. Okay. Discover. What a great name, right? Because that's literally what I want to do right now, is I want to discover my log data. So I'm going to push the discover button. And here we are. We're kind of back to that interface that we saw at the beginning, but this time, you know, I'm looking at the Ruby on Rails bag. And, you know, you're pretty much there. Couple more pieces to think about in the discovery interface. As you saw from Martin's talk, there is an Elasticsearch query DSL that is stupid powerful. You don't have to use it if you don't want to, but like, I can just hit this button that says filter for value, and now it'll only show me the data that is relevant for that, and I could go in here and I could edit this, and I could write a really awesome thing, and I could save that and, you know, generate reports and blah blah blah. But I just, you know, this is kind of a monster. Not going into it. Less than 10 minutes here. There's another query DSL in the Discover interface. It's not immediately obvious at first that you need to know two query DSLs to like operate this tool, but sometimes you do. The other one is the Apache Lucene query syntax, and again, like, this one's actually fairly simple, but it's more of like, okay, I'm back in this tool, like, I got my stuff, and now it's like, what do I need to Google to find the thing that I want? Well, it's probably one of these two. And then last but not least, I did want this talk literally to be able to let you go home and put this into production. And the thing that you need to do if you're going to make production systems not suck is least privileges. Right? We do not want to install FileB on our application servers with the Elastic user. So this is mostly just a reference for the audience here and for people out in TV land and for the future. These are the minimum privileges you need to configure for your FileB user. And these are the minimum roles and privileges you need to configure to let someone on your team access these logs. And that's pretty much it. We did all 5 steps, and we can now see logging data in real time. We can search for it, and we're not going to pay a fortune to do it. So that's it for me. I really mean this when I say this. Thank you. And I really mean it. Come visit me. I live in the Caribbean. You come visit me. And I'm on Slack, and I'm ready for questions. So cheers. Thank you all. All right, let me see if I can get DOS questions. No, okay, continue recent. Continue. There's questions in here. Oh my God, this is amazing. All right, what do I do? How do I present this? Richard. Hey, Richard. Given the immense amount of data you have you considered using it for any kind of reporting or analytics? No, not really. I was really impressed with Mr. Moriarty's talk from yesterday, and when I see that level of like, whoa, these guys got it together in analytics, I'm like, I just want this nice little tool that's for developers to go in there and solve their customer support mysteries. You could do that, and maybe if you have one of these BI platforms that can suck data from all the places, maybe that is just one more data source to pull from it. So I personally haven't really thought about it. I made this tool for me, but you're right. It probably does have some BI relevance. So cheers, thanks. Hey, Richard. Have you looked into Splunk or log entries and friends? If so, why didn't you go with them? Selfish, self-serving reasons. Mostly, I wanted to learn about Elasticsearch. I wanted to give a talk about something that I thought solved a need in our community, and as the record shows, there is a need. I just thought that this was a fun combination of tools to do it with. And I'm sure these options could work. I just don't know how to make them work right now. And that was kind of my goal, was to like, if I can do this in 30 minutes live, there's absolutely no reason, and for $45, $90 a month, there's absolutely no reason anybody shouldn't be doing this. I'm not sure if that was right. Okay. And again, I'm definitely happy to hear about why I should consider those alternatives. There's probably great reasons.